Hello and welcome to this troubleshooting tips series. When returning TI components, it's important to reference TI's quality and reliability processes that can be found on ti.com/quality. For more troubleshooting information, please refer to ti.com/troubleshooting. Do you suspect a TI product to be non-conforming to datasheet electrical, mechanical, or image quality specification? And would like to learn more on TI's return process? Then this troubleshooting tip series will give you helpful guidelines when returning a product to TI. Here's an overview of the 5 key items of TI's guidelines for returns. In this video, we will guide you in the first step of your verification process, if you suspect an issue with a TI product. In the following, we will learn about the ABA swap, which is a great board-level troubleshooting technique. And in addition, it will help TI to understand your concern with a suspect TI product, separate from any application issue you may experience. This enables an efficient and effective quality review. Before we start the verification, it is recommended to perform an optical inspection. Automated inspections are generally completed during the application manufacturing process. However, some hidden assembly anomalies may be overlooked by the automated tool. Low-tech assembly issues can easily be missed without a visual inspection. Examples are bent leads, solder bridges, flux contamination, damaged traces, or IC orientation. Finding such assembly issues in an early phase could avoid spending countless hours troubleshooting an application. Therefore, a manual optical inspection should always be completed before any other analysis technique. Key inspection areas are leads, surrounding circuitry, and connected traces. Now let's come back to the benefits of an ABA swap. It can be applied to both complex and simplistic circuits. It helps to check for assembly anomalies, which can result from resoldering, reflowing cold solder joints, and also cleaning solder flux residue. The ABA swap is also a key action of the customer's pre-verification to confirm that the observed issue is working with the TI product, meaning that the non-conforming behavior follows the TI product under test, independent from the board it is mounted on. So how does the ABA swap method look like? The ABA swap methodology starts with 2 printed circuit boards and 2 components of the same model. More specifically, the suspect TI product A and the known good TI product B. The first step is to remove the suspect TI product A from the original failing board and the TI product B from a known good board. TI recommends to utilize an automated rework station, or if not available, a solder rework station with a heat gun to complete this process. In addition, a vacuum picker will help us removing the component from the PCB. Now that the components are removed from the boards, we replace the suspect TI product A with the known good TI product B. Once soldered, we can check whether the original failing board is working correctly or the issue is still observed. Finally, we solder the suspect TI product A to the known good board and see whether the previously observed issue continues to occur. The last step is critical to exclude the possibility that the issue is caused by an interaction with another component on the board, or that the issue is related to a cold solder joint, flux contamination, or any other printed circuit board assembly anomaly. Now that we covered this part of TI's guidelines for returns, it is important to mention that TI has additional collateral on ti.com to help with troubleshooting and debugging. As shown here in the slide, we see that TI has various quality policies and processes, as well as an E2E support forum and TI Precision Labs. Thank you for watching this series on guidelines for returns. For additional videos, please visit ti.com/troubleshooting.